Hi everyone. Remember when you learned how to add and subtract numbers, fractions like this? It's harder than multiplying them. If I were multiplying these two fractions right here, I would just multiply straight across the top, get a 2, straight across the bottom, and I'd get a 12, and I'd multiply these. But when you add and subtract, you need a common denominator. So adding and subtracting is more work than multiplying and dividing. But if we can remember the rules for here, then they will apply when we get to rational expressions. So first of all, when I look at this, what's the lowest common denominator? Well, it's a 12, right? You have to take at least what's there. There's a 12 there, so I certainly can't go lower than a 12. A 12 is going to have to be one of my common denominators, but I can go higher. But 12 is going to work. So I have all my denominators are now 12s, and the 5 over 12, I don't need to touch that because it's already done. So what did I have to do to this 3 denominator to get a 12? I had to multiply it by 4. I'm doing the same to the top, so I'm reviewing the steps that we need for below. That's why I'm doing this right now. So my new numerator is going to be an 8. And what did I do to the second denominator, the 4, to get to a 12? I multiplied by a 3, do the same to the top, and we get a 3. And now we have a common denominator, and we can add them all. I kind of ran out of room here, but we could put them all over one denominator, 8 plus 3 minus 5. Okay, so now that we've reviewed that, let's apply those skills to rational expressions. Looking at the first question here, A. We've got a denominator of 5 and a denominator of 3. So what's the lowest common denominator? Remember, it has to be at least as big as your biggest number there. So we're going to just multiply these two together and get a 15. So I'm going to have a common denominator of 15 here. So this is 15 and this will be a 15. What did we have to do to the first denominator of a 5 to get a 15? Well, we multiplied it by 3. Same to the numerator, multiply by 3. We now have a 3x. And what did we do to the second denominator to get 15? We multiply by 5, so we do the same to the top. Now it's a binomial, so I'm going to put brackets on because that's really going to save me from helping me to remember to distribute. When I multiply that numerator by 5, I get 5x minus 5. So now I have one denominator, it's a 15, and I can add my numerators, 3x plus 5x minus 15. That's a 15 there. And that's going to give me 8x minus 15, sorry, 5. I don't know what happened there. That's a 5. Go back to that. 5x minus 5. 8x minus 5 over 15. Okay? So if you didn't understand that one, you got to pause it and watch it again, because every example I do is going to get harder. We're not going to even have numbers for denominators. We're having letters now. So make sure you understand those concepts before we move on. Next one. Okay, so there's no numbers here, but we have letters. So remember what I said, your common denominator has to take at least the biggest thing that's there. In this case, it's an AB. So my common denominator is going to have to be at least AB. It can't be just an A. Now, could it be AB? Is there something I could multiply the first denominator of A by to get AB? Yeah, I could multiply it by B. So I can have a common denominator of AB. AB. Now my 3 is already good. I don't have to worry about that. Erase this. So my first denominator was an A. What do I need to multiply an A by to get to an AB? To get to this denominator? I'll multiply by B, do the same to the top. 1 times B is B. And then my next line is B minus 3 over AB. So that is a little more complicated question than part A, but it's getting into some letters now. And we are going to talk about restrictions for sure, but we're just going to work with common denominators for a minute here. Next slide. As with all fractions, you need to find a common denominator before you add or subtract. So I've got some steps here. We'll go through these. Example 1, simplify each of the following and state restrictions. So look at these denominators. Oh, okay. They're not as easy even as the last one, which was just A times B. We've got binomials now. But we've got some steps to help us guide our way. Step 1 is to factor. Can any factoring be done here? Well, not with monomials. You can't factor monomials. Binomials can only be factored if there's a common factor or a difference of squares, which we have here. So my first line, I can factor the first denominator, but that's the only thing that's going to factor here. X minus 3, x plus 3. And then the rest of the question, we're not doing anything with the factoring, and we're just on step 1 right now. So I'm going to just leave all the rest of this alone. Step 1 was to factor, so that's done. Step 2 is to state restrictions. What can x not equal? So we look at all of our denominators. For this denominator, what can x not equal? X cannot equal 3. How about the second chunk? That's a negative 3. And what about this piece? Well, that's a 3, we already have that, and that's a negative 3, and we already have that. So we've got both of our restrictions there. Next step is common denominator. Okay, so here's the hard step here. So focus. Common denominator. Remember all the examples I showed you before? The first one I had with a denominator of 12? Well, that's kind of like what this one is right here, because this denominator is actually both of these together, right? Here's the x minus 3, here's an x plus 3, and here they both are together. So imagine this denominator was a 4, and this one was a 5. Well, then this is your 4 times 5, this is your 20 right here. So my common denominator is going to be this part. That's already common, so this piece is already done, but these pieces are going to require another factor in them. So my first term is still 6x over x minus 3, x plus 3, but now I take my second one, I'm going to make my line a little bigger here. I'm going to put my x minus 3 in brackets because it's a binomial and it helps to do that. What's it missing? What is this denominator missing that this denominator has? It's missing an x plus 3. So I multiply top and bottom by x plus 3. Next one is plus 3. I'm going to make my line a little longer there. And I'm putting a bracket around the denominator so I keep it together. What's it missing? What's this x plus 3 missing that this denominator has? It's missing an x minus 3, so I do the same to the bottom that I do to the top, multiply by x minus 3. Now I have a common denominator, and my common denominator is x minus 3, x plus 3. Or you can write them the other way, it doesn't matter. My numerators, I've got a 6x, I've got minus 2 bracket x plus 3. Now that minus, I could have distributed the 2 here, but I didn't because I was a bit worried I might forget to also distribute the negative in. So I'm just going to rewrite the brackets x plus 3 plus 3 x minus 3. So now, looking back up at our steps at the top, we factored, we stated restrictions, we found a common denominator. Now we have to simplify the numerator, and that's why it says watch for negative signs, because it's very common to just want to distribute here and write 2x plus 6, and then you end up just making the first term negative 2x, but you keep it a plus 6. But this negative sign means this, look at the original one here, we're subtracting this whole fraction, we're not just subtracting 2, so we have to subtract everything that goes on there. So now, I think I'm going to run out of room. My numerator is 6 minus 2x minus 6 plus 3x. And then 3 times negative 3 is minus 9. And that's all over my denominator of x minus 3, x plus 3. So when we run out of room, we use an arrow to show where you're going with it, and I'll have to erase this in a minute because I'm going to run out of room, but I'm going to move it all up here. What have I got on my denominator now? How many x's have I got there? Let's collect our like terms. We've got 6x minus 2x, which is 4, plus 3x, that's 7x. And what about the constants? The minus 6 minus 9, so that's minus 15, over x minus 3, x plus 3. And back up at my steps, We simplify the numerator. Factor numerator again and cancel if possible. This step 5 is often not possible, and it's not possible here, right? I can't factor that numerator. But let's just say, let me put another color in here. Let's say this were a 5. If that were a 5, then I would factor out a 5. I'd be left with x minus 3, and I'd be able to cancel that with this one if factoring was possible, but it often is not. So I just wanted to show that to you. So we can't factor here. So we can't do anything with step 5 because we couldn't factor our numerator. Step 6, answer and restate restrictions. So this is our answer. All I have to do now is restate my restrictions in order from low to high. X cannot equal -3 and +3. There we go. I'm going to have to erase this part here. So press pause on the video because when you, in 1 second, it's going to be disappeared. I'm going to erase it. Part B. Yeah, this one's even harder. Okay. Well, we'll go over that in a second. We've got a monomial denominator, which is simpler actually. But over here we've got, it's already factored. Step 1 is already done. It's already factored. There's a monomial common factor that is a p, and then we have a binomial, a p plus 1. So step 1's already done. Everything is factored. There's more factoring that can be done. So step 2 is to state restrictions. What are the restrictions? Do you remember the rule when you have a monomial denominator, what the restrictions are on it? The restrictions are the p. So if you've forgotten, I'll write it out for you. You've got p squared, that's this denominator, and that can't be 0. So I want to isolate p, I take the square root of both sides, and we get p cannot equal 0. Anytime you have a monomial denominator, it's always going to work out to be a 0. So this first denominator we have has a restriction p cannot equal 0. What about this factor? Again, it's a monomial, it's going to have the same restriction. What about this part of the denominator, p plus 1? That is going to have a different restriction, and that's going to be p cannot equal -1. So there are 2 restrictions. That's step 2. Step 3 is the common denominator. Okay, common denominator. This is the hardest part, right? If you can get to step 3 figured out here after today's lesson, then you're in a really good place. Common denominator. So this one's different because we have monomials and binomials. Over here we had all binomials. So first I'm going to do the monomials. I have a p squared and a p. What is just between those two? What is the lowest common denominator? And if you can't make sense of that, always change it to numbers you do understand. Let's say p were a 5. So forget about the numerator. If the p were a 5, we would have just this would be a 25. And this part here, I'm just looking at the monomials. Monomials would be a 5. What would the common denominator be if those were 5s? Well, it would be a 25. You have to take at least the biggest thing that's there. So we have to take the p squared. So between a p squared and a p, the lowest common denominator is p squared. So the monomials, the lowest common denominator for the monomials is p squared. So that's good news. I'm going to need more there. Put some more space. I've got a p squared there minus p squared. So those are that's what I need for my monomial denominator. Now let's look at the binomial. I only have one binomial and it's p plus 1. This one's totally missing a binomial. It's going to need it. So I'm going to have to take this p plus 1 and it's going to go here and it's already here. So I'll do p plus 1 now gets brought into my first denominator, which wasn't there, and it was already in my second denominator, p plus 1. Now numerators. So I had a 3 and a 2. What gets brought into it? How do I get from p squared to this denominator? What is new? Well, this part is new here, p plus 1. So I'm going to, I'll put it in purple. I have to introduce a p plus 1 in the numerator as well. So think about this, just this first piece. If I canceled right here, this would cancel with this. I'd be right back where I started, which is what we want, right? We've got to keep equivalency. 3 over p squared, that's the same thing. I just introduced a multiplication by a factor of 1, really. Now look at the second one. What does the new denominator have that the original denominator was missing? Well, it's got an extra p in it, p squared. So I'm going to have to multiply my numerator by a p. So now we have a common denominator, which is p squared times p plus 1. And my numerator is, so I don't have a minus sign in front of this one, so I'm going to go ahead and just distribute that in. 3p plus 3, because I'm on step 4. Step 4 says watch for negative signs, so I'm just going to write that one out. Since this is a monomial here, the negative comes into the 2p. I don't have to worry about distributing any further than that. That's step 4. I'm still on step 4 because I haven't finished simplifying my numerator. So 3p minus 2p is p, and then the only constant I have is a 3 over p squared times p plus 1. We're on step 5. Factor numerator, again, if possible, cancel if possible. If there's no factoring to be done, so I go to step 6, answer and restate restrictions. So that's my answer, and my restrictions in order are p cannot equal -1 or 0. Example 2. If the following were denominators, state what the common denominator would be between them. So this question I just kind of made up just to give us practice with denominators, but what I'm saying is, imagine that's just a denominator and that's a denominator, but instead of me writing them all out and confusing you by thinking, well, what would the numerator be? I just want to look at denominators. So for part A, what's the common denominator? So first we look at monomials. This one has a single x, this one has a single x, perfect. Our denominator is going to have a single x. Now we look at binomials. This has an x plus 2. This does not. We need to introduce it here. So it needs an x plus 2. So this is our common denominator. So this is a denominator. We would have some numbers on top or terms. That's the common denominator. What about b? Okay, b, we need to factor this first one into x plus 2, x minus 2. So again, these are denominators. Imagine this is 1 over that, and this is 1 over that. What would the common denominator be? Well, they both have a x plus 2 binomial, so for sure we're taking that. Are we missing anything else? Yeah, we're missing the x minus 2. So that's the common denominator. If we were finishing the question, that would be your common denominator. How about C? Denominators. These are just denominators. What is the lowest common denominator? We have two binomials. So we have two binomials that are completely different from each other. So our denominator is going to have to be both of them, m minus 3 and m plus 1. That would be the denominator. Why don't you try D on your own? Press pause, do it, and then come back. Let's look at D. We're going to look first at, so remember these are denominators. These are denominators. I'm going to look first at the monomials. This has a y squared, this has a y. I have to take the biggest one, I have to take the y squared. I can't just take the y because then this is missing something. So y squared will be part of my denominator. That'll be the monomial part. And then the binomial part, I've got a 5y plus 3. I've got nothing here, but I need a common denominator, so they both need the 5y plus 3. So 5y plus 3. And hopefully you did press pause a minute ago and you got that answer on your own. That would be your denominator. Last one is E. We've got a lot of binomials here. There's an x plus 1 here, but there's no x plus 1 there. So I'm going to need an x plus 1 for everything. There's an x minus 2 squared, so there's two of them. So imagine not this pair of 2 here, but imagine x minus 2 written out twice. This one's only got 1, and it's going to need 2 in order for it to have a common denominator. Remember we talked about the squareds, the 5s before? We said if you had one with a denominator of 25 and another one with a denominator of 5, you have to go with the bigger one. This is your common denominator. So I have to take this whole thing as my common denominator. So first let me write down, we already said we need the x plus 1. That needs to be in both. Now let's look at the x squared, x minus 2 squared. That needs to be in both because the other one only has one x minus 2. It's going to need 2 of them. X minus 2 squared. So we've got everything from the first set. I've got all those denominators. Now here are more denominators. There's an x minus 2. We've already got 2 of them here, so we don't need any more. We've got enough x minus 2's, but we don't have an x plus 4. So we also need an x plus 4. So that would be that denominator. So that's just some practice with denominators where you don't have to do all the numerator stuff because that's long, but I just wanted to practice some denominators. Example 3, simplify and state restrictions. Okay, step 1, do you remember? Because it's not on our sheet anymore. You're going to have to flip back to look for it. Step 1 is to factor. Factor, what can we factor? Well, our first numerator is a binomial that cannot be factored, so I'm just going to rewrite that. What about our first denominator? That looks like it might be a trinomial, an easy trinomial. Let's see, are there 2 numbers that multiply to -3 and also add to 1? Yes. So we're going to factor that to x plus 3 and x minus 1. Minus. Okay, our first numerator is, can't do anything with that. We're just on step 1, which is factoring. And the second denominator factors to x minus 1 and x plus 5. X plus 5. Step 1. Step 2, state restrictions. What can x not be? Looking at the first piece here, okay, x can't be a -3. Second piece, x can't be a 1. Third piece, oh, we got a 1 again, so that's good. And that's a hint about our common denominators. If I don't have to repeat, if I have repeated restrictions, I'm going to have repeated parts of my common denominator. And this is a -5. Okay, and there's a great time to press pause and get your common denominator yourself. Just do that, just write out the common denominator. Okay, have you done that? So let's do it together now. What do I need for a common denominator? Well, let's start at the front. I've got an x plus 3 here, and I don't have it anywhere else, but it doesn't matter. I need an x plus 3, so there's my first binomial. I should have mentioned there's no monomials. I would have started with monomials, but I don't have any. So my first binomial is x plus 3. I definitely need an x plus 3 in my, better make a big line here. I definitely need an x plus 3. My next binomial is an x minus 1. And luckily it's repeated here, so that'll help later when I'm changing my numerators. It's already got an x minus 1. I don't change it to squared. Sometimes that's a tendency. You're like, well, there's 1 here and there's 1 here. I better put a power of 2. So again, remind yourself of numbers. Let's say we had 1 over 5. Say x minus 1 is 5, and then I have minus 2 over 5. Well, it's common. I don't have to say, oh, my common denominator is a 25. No, my common denominator is just going to be a 5. So I just have to write it once, x minus 1. Next is the x plus 5. So I have an x plus 5 here. That's got to be on both. It's only on the right-hand side. It's got to be on both, x plus 5. And I'm going to just duplicate that and write it all out again. I need to erase some of my work first, though. So I have 2 sets, so I've got to write it out twice for now. And some of us can maybe start skipping having to write it out as 2 separate denominators, and you can go right to 1 common denominator. Maybe we'll try that on the next one. Numerators. My first numerator was an x plus 1. I'm putting brackets around it, and that's a really helpful step to keep it separate, keep it together when I go to multiply later. What is this denominator missing that the common denominator has? What's it missing? It's missing an x plus 5. So I'm going to put an x plus 5 in the numerator. And again, what that means is this x plus 5 over x plus 5, these are equal to 1. So if I canceled, I'd be right back where I started. Okay, so that shows me that what I've done is good because everything is still equal. Sometimes we put it in the denominator and we forget to put it in the numerator. So make sure you put it in both. My next numerator was a binomial, x plus 2, but now it needs something else. What does it need? It's got an x minus 1 and x plus 5. We've got an x minus 1, x plus 5. We also need an x plus 3. X plus 3. So now I've got some binomial expansion to do in my numerators, or FOIL. So that's why it was a good thing I put the brackets on, because now I see I have to multiply this x into both of these terms, this 1 into both of these terms. And when I do that, I'm going to get x squared. And I'm going to put the two together at once. So I'm going to have plus 5x plus x. So that's going to give me a plus 6x. We're in grade 11 university. I think we can add those two together in our heads. But if not, then write them down. And then plus 5. Minus, careful of the minus sign. So because of that minus sign, I'm going to put a bracket here, and I'll distribute first. I'll get x squared. Then I'm going to get a plus 2x and a plus 3x. That's going to be a plus 5x. And then plus 2 times 3 is a 6. So the reason I put the bracket up is because I knew I would forget. And I would just, if I didn't put the bracket up, probably a lot of us would have just written this. And then later when we collect our like terms, we believe that this is the only negative here, right? And this state of positive and this state of positive, but they shouldn't. We have to subtract the whole numerator. And this all goes over my denominator of x plus 3, x minus 1, and x plus 5. Now I bring the negative in, and I'm going to do 2 steps in one. Again, this is grade 11 university, we can do this. So this is going to be negative x squared, and I have a positive x squared at the front, so these are actually gone. I have, let me change colors, I've got a positive 6x here. This is going to become a negative 5x. So what am I going to be left with there? I'm just going to be left with a single x. Get my numerator going here. I'm going to be left with a single x. And how about the constants? I've got a plus 5, and this will be a minus 6. Plus 5 minus 6 is going to give me minus 1. With all of my denominators, x plus 3, x minus 1, and x plus 5. So there we are at our step 5, which says factor numerator again. I can't. But it says factor numerator again and cancel. Okay, I can't factor, but can I cancel? Well, putting brackets here might help me to see this is a binomial. Remember, we can cancel binomials if they match exactly. They do. It's the first time we've had this. These match exactly. They turn into ones. They cancel into ones. So what I'm left with at the very end is an answer of 1 over x plus 3 times x plus 5, and I'm going to restate my restrictions in order. They are x cannot equal negative 5, negative 3, and 1. Okay, that was a longer question. Lots of binomials to work with. Always good to practice twice, right? Try to go back up, rewrite this on a scrap piece of paper, do the whole thing yourself. Can you get the same answer? Let's look at B. Last one. Step 1 is to factor. Take a look. Can anything be factored? Yes. I also have this note here, follow BEDMAS. That's because this is multiplication. This is our first, we've been doing lots of addition and subtraction, but here we have multiplication. That means I'm going to have to do this first, right? Multiplication has to be done before addition and subtraction. So I'm just going to put those brackets there right off the bat so I don't mess anything up. But first I'm still going to factor, but since I noticed the multiplication, thinking of it, I'm putting the brackets up right away. 15 over, difference of squares, x minus 1, x plus 1. Extend that over there. Nothing else, there's no more common factors. Actually, I'm going to rearrange this. Instead of 4 plus x, I'm going to write x plus 4 because that's the way we normally write terms with the variable first. Over, and instead of, here's my bracket, instead of 1 minus x, that one's a little harder to rearrange, but it's a negative x plus 1 times x over x plus 4. So before we do addition subtraction, which is the whole common denominator thing, before I do addition and subtraction, I have to do multiplication. So I got to do this first before I even look for a common denominator. I could get a common denominator for everything, but I have to multiply this anyway next before I put it all together. So there's no sense doing common denominators when it's just adding work. We want to follow BEDMAS. And I should emphasize when I say you could find common denominators first, you could write this out and this out, change the denominators, but we couldn't actually do the subtraction piece of them until the multiplication's done. So let's do the multiplication first. Remember how to multiply. Oh, sorry, we have to do our restrictions. Restrictions on this one. X cannot equal 1 right here. X cannot equal -1 right here. What's that one? That's also a 1. And here, a -4. Now, if I had a division sign in between, I would also need the restriction on the numerator there, but I don't have a division sign, so that's just a little review for you. Okay, so step 1, factors. Step 2, state restrictions. Now, before we add and subtract and get the common denominator, we need to do this multiplication first. Looking at the square brackets that I set up here. Multiplication, I could multiply straight across the top, straight across the bottom, but remember from your steps, if you can cancel, I'm going to put brackets on all these binomials so I don't mess them up. If you can cancel, now's the time, and I can. X plus 4 and x plus 4 are exactly the same. They're going to turn into 1s. But this is a monomial, and this is a binomial, so they can't cancel. You can't do that, and if you've forgotten that, you need to go back and review that. So that helps a little bit. It actually takes some stuff away from our question. It made it a bit smaller. X minus 1, x plus 1. But now what we've got in our bracket here, our numerator, we multiply now. We have 1 times x on the numerator, that's x. On the denominator, we have just -x plus 1. -x plus 1. So that's easier. Now that we've done multiplication, actually I can get rid of the brackets because I'm going to move on to common denominator now. I'm going to go and do the subtraction. So let's look at the common denominator. We have an x minus 1, an x plus 1, and a -x plus 1. Are any of these the same? We talked about this in our last lesson. When we have this, originally it was 1 minus x, right? Remember we talked about 1 minus x and x minus 1. Are they the same? Well, here's another way for me to show you that they're almost the same. I'm going to leave the first set alone, x plus 1. But what I'm going to do is I'm going to divide a -1 or factor a -1 out of this first bracket. So when I do that, I pull out a negative and I'm left with a positive x minus 1. So these two now are the same. I just had a negative. Remember the rule is a minus b is equal to negative b minus a. So we had x minus 1, and that's the same as negative 1 minus x. So now that I've pulled out a negative, I can say that they're part of a common denominator. And if I didn't notice that, I would just have a bigger denominator, which would kind of cancel it later. So now my common denominator. Okay, what's the common denominator? Well, we know x minus 1 is in there. X minus 1 for sure is in there. I'm going to put these, don't worry about the negative, these two are going to come together right here and they're going to make a positive. So that's the beauty of just pulling out a negative. It doesn't affect your denominator or your factors. So they both need an x minus 1. So this is now a plus sign. They both need an x minus 1. What else do they both need? They both need an x plus 1. They both need an x plus 1. So my first numerator already had all that, so 15. My second numerator just had an x. What did we introduce there? We introduced an x plus 1. So now all over one denominator, put it all together, x plus 1, I've got 15 plus, I'm going to distribute this, x squared, plus is nice, I don't have to mess around with my signs, plus x. So that's a trinomial. Let's take a look at that. I'm going to cram that in down here. That is x squared plus x plus 15. Is that trinomial going to factor? Trinomials often do. Is there anything that multiplies to 15 and adds to 1? Well, there isn't. Oh, it looked good there for a minute, but no, there isn't. So I can't go any further with that. I can't factor and then maybe cancel X more. So I'm at my final line, and the restrictions are X cannot equal -4, always low to high, -1, 1. There you go. Adding and subtracting rational expressions. Very complicated. And if you don't know your adding and subtracting of just plain numbers, then this is even more confusing. So this is a good video to watch a second time, or to watch another video that someone else has made on this. The second time through is going to make so much more sense than the first time through. It always does. So I encourage you to watch another video, or watch this video again, or do the examples again, do some repetition, and then definitely, of course, do your homework.